All right, so in this video, we're going to see how heat and mechanical work relate. And this is from the work done by James Joule. And I put another video on Canvas that walks you through a bit more history of what's going on behind this. And so this was all done experimentally. And the idea was to show that heat is just another form of energy, just like all of the energies that we've studied so far. And if you look at the little experiment that is shown over here, there's a lot going on. But the idea is that you have here a container with some water, and we can measure the temperature. And so you can see that inside of this water, you have some paddles, and they are connected to an intricate thing that, so here you can apply mechanical work, and essentially can lift masses, and they are going to drop down due to their weight and lose potential energy. As they do, that's going to make this whole system rotate. And the friction between the paddles and the water is going to make it so that the temperature of the water is going to increase, which is something that can be measured here with the thermometer. So the idea is that then that means that you're able to turn mechanical work here into heat and measure the exact equivalent. So essentially, if you look at the change in potential energy and you look at the work that's done here by the masses, you can look at exactly how that got turned into a change in temperature. And given um, the water that you have here, you can convert that to a direct amount of heat and look at the equivalence between the two. So if you look at the units of heat, it means that heat can actually be measured in joules as well as in calories. So typically, when we refer to heat, most of the time we actually think about the calories, and color means essentially it's something that directs directly to the concept. But as it turns out, this is the same thing that joules measure. And so a calorie, and we have to be very careful with notations, the calorie is the amount of heat needed to rise the temperature of 1 gram of water by 1 Celsius degree. And 1 calorie, and just be very careful, it's a little c over here, 1 calorie is equal to 4.18 joules. Now, this is something that we use a lot in our everyday life. If you look at your food intake, for example, this is something that we measure. We always talk about the number of calories that we ingest, but this is actually calories with a capital C. As it turns out, calories with a capital C is kilocalories. It's extremely confusing, right? So a calorie with a capital C is not the same as a calorie with a lowercase c. A calorie with a capital C is actually a kilocalorie. So if you look at 1 calorie as given by the food labels that you have, it's actually 1,000 calories according to the our notations here. Okay, so it wouldn't be 4.18 joules, right? It would be 4,180 joules. Okay, so you want to watch out. But so I have another video that I'm going to post here to talk a little bit more about this. But this is important in terms of our understanding of what's happening here with thermal physics. Because it was not obvious for a long time that that heat that we've been talking about is actually something that is equivalent to an energy. And so Jules was actually able to show the direct measurement of, if we look at this experimentally, we can actually figure out the equivalent um, amount of mechanical work that would generate the same in terms of heat energy. Okay, so and essentially, instead of having these, and essentially establishing this relationship here between calories and joules and showing that they're actually equivalent. Um, and the idea is so you can essentially raise, right, a certain amount of water by a certain amount of degrees, and that's how, you would look at how much work was put into doing that, and that's how you can figure out the equivalent. This is important because coming up, we're going to talk about the laws of thermodynamics. And especially when we talk about the first law of thermodynamics, we're going to see that we're going to be able to relate the heat exchange to the amount of work done, maybe by a gas or something else, uh, to also the internal energy of our system. All right, so these are all very important quantities. They do describe something conceptually different, but they are all measured in joules. All right, thanks. Bye.